Hello, everyone, and welcome to episode 53 of Nutanix Weekly. I'm your host, Andy Whiteside. Got Harvey Green with me, who is kind of local. He's, 45 minutes away by car, and Jirah's now 2.5, 3 hours away by car. We were just debating define local in 2022. Harvey, what was your answer to how you define local in 2022?
I told Jirah that the latency between where he is and where I am round trip in my car isn't what it used to be at all. So he's not as local as he used to be.
Yeah.
If I recall my high school physics, saying I'm 2.5 to 3 hours away makes certain assumptions about speed.
Well, yeah.
I defined in my car.
Well, and you're really saying how fast can I get to you? In this case, get there and get back and somebody acknowledge that you got there or not. This is really good for what we're going to talk about here in a second. But, so Harvey, I'm not doing it today, but let's say I were to leave my office and go pick up my kids at school. I know exactly how to get there.
Yes.
But because I don't know what traffic's going to be like where I live or where you live, it's a nightmare. I'm sure where Jirah lives now, probably not a nightmare too.
Yes.
I don't know how I'm going to get there because I don't know what the traffic situation is going to be. Therefore, I use smart software, okay, like an SD-WAN type of thing. But in this case, I use GPS, and it's in my car. I turn it on even though I know where I'm going. And occasionally it's like, oh, no, don't go that way. You need to go this way. And I got to be stubborn. Oh, I'm going this way. And then I go the way I know. And like, oh, no, car accident, 3 hours sitting in traffic, which kind of maybe takes us to our topic for today. And I asked about, we were talking about stretch clusters the other week. And I brought up Metro. No, what's it called? Metro clusters.
Metro availability.
Yep. And Jirah has brought that topic for today from the Nutanix community blogs, step-by-step guide to deploy Nutanix Metro availability.
Yeah, so Jerome wrote up a fantastic blog post here. I love how our community blog engine assigns him the label of trendsetter. Fantastic. Congrats, Jerome, on your trendsetter status. And yeah, I think another fun connection to make here between you driving somewhere you already know how to get to, but the value is the software, as you called out, but also the data, right? The real-time data of how are the roads running, right? And what do I want to avoid as I get from A to B there, has a lot of applicability, right? Because we can use a Metro cluster, obviously for worst case scenarios, but there's value in even not all the way to worst case scenarios as well, right? So we can use it for say planned maintenance, right? If I know that I need to get ahead of say generator maintenance or transfer switch or UPS maintenance, maybe I want to go ahead and just move my workloads over to another data center anyway, right? Rather than trust that UPS maintenance is going to go totally smoothly.
Yeah. Because look, the goal is to get there and get there as fast as you can, but you want to get there in one piece. So getting there is the most important part.
Yeah.
We have become overly with the idea of the acceptance that we have to get there fast. And, that's today's age, but getting there all in one piece is the goal.
Yes.
Totally.
No packet or limb loss.
I can't. Agreed. Yeah, I can't end that. Yeah, there you go. This podcast is officially against limb loss. Yes, yeah. Well, I'll plant that flag.
No blood and guts and gore on this podcast.
That's right.
So
no data loss either, though.
Totally no data loss. No chance of data loss. So to start painting a word picture here, right? In Jerome's right up here of his, I think this is a lab deployment. So start off with 2 Nutanix clusters. So we want one cluster in site A or availability zone A or data center A, another cluster in site 2, availability zone 2, data center 2, however you break them up. The entire point, right? The end state of deploying a Nutanix Metro cluster, which is really 2 Nutanix clusters and then one, in this case, this is using vSphere as the hypervisor, which is not required. You can do it on AHV as well. Is the outcome of, all the humans are asleep at 3 a.m. One data center goes fully dark, loses power, let's say. I want all workloads to automatically resume at the other data center And to your point, Harvey, I want zero data loss, right? So just as if the VMs crashed at one site and they will power on at the other site, as if it was an HA event from node to node within one cluster, but we're going to cross a larger geography than just within one cluster, right? We're not going from blade to blade, node to node, rack to rack. This is going to go from data center A to data center B, right? Is the expected and desired outcome. So to do that, we've got our clusters at each site, because each cluster is an autonomous unit, right? So I'm going to write, in this case, probably 2 copies of data on cluster A, 2 copies of data on cluster B, keep them in sync. And then with synchronous replication, right, no data loss, I wait for that remote acknowledgement. So if a VM's running at site A, I wait for site B to tell me, hey, I've got that data as well, before I acknowledge back to the guest VM, hey, I've got your data, right? So the write doesn't succeed to the guest OS until we've got data written on both clusters. So within each cluster, then, then on each cluster, I create a local data store, basically, or a data store that goes from data store site A to B, and then at site B, I create a data store, a container from site B to A. So I've got both my directions there. Jirah uses the nomenclature Metro 1-2 and Metro 2-1. But basically, it shows in the labeling, right, for a human to see these are VMs that replicate from one site to another site and what the direction is there. So we can keep it straight as we're like building out a new VM in our VM creation wizard.
So Jirah, I've got cluster number 1 in building 1.
Mm-hmm.
And then how far away can cluster number 2 be to do this? And how much redundancy do I have to have?
So the
Network
distance is not set by, the how far away is not a factor of distance, it's a factor of latency. The book says we want to be 5 milliseconds away or less. In reality, we want to be as close to the or less as possible. If you tell me that the link has 4 milliseconds of latency from end to end, then that's 4 milliseconds you're going to add to each and every single write for the life of the cluster, right? You're slowing down all VM write operations by that delay. So we want that to be as low as possible. 0 milliseconds, 1 millisecond is much, much better.
So that's very, very important that you bring that up, because one of the things that we talk about a lot with Nutanix is the acknowledgement of rights, and Andy kind of went into this a little bit too. But you want to make sure that you've got the optimal set, and that you're not killing yourself performance-wise to try to make this work, because you actually are waiting on that latency to take place before those rights are acknowledged. Is that right?
100%. Yeah. If a VM lives at site 1 and you've configured it for synchronous replication to site 2, then it's going to wait until site 2 says, I've got that data before it can proceed.
Yeah. So for all the people who haven't been doing this very long, they say, well, 4 milliseconds, that's nothing. I got, 30 or 40 or 50 or 60 between this site and this next site. Why would I care about 4?
Because it's a lot for your storage system. If your laptop started adding 60 milliseconds to everything you did on your laptop, you would be making some phone calls or looking for a new laptop.
Right. And so that's for the big answer behind that is that's 4 milliseconds for every write.
Every single write.
Yeah.
So guys, are we really talking fiber configurations in order to get this done? Can we do that with copper these days?
The medium doesn't matter too much. Well, to be at any kind of meaningful distance, you probably would be fiber away.
Right.
You could, you could use copper technically to be properly agnostic. It almost becomes a function of availability planning, right? And like shared nothing. So could I get from like a data center hall to data center hall? Like we have some regional data centers around here that have multiple kind of shared nothing availability zones within one roof. And if you wanted to do that, of course, you totally could. But normally, most customers would be looking to go like across a city, maybe across a state, depending on what size of state you're sitting in when you listen to this. New England, yes. Texas, maybe not. In general, 50-ish miles, I've heard, is kind of a typical translation of the kind of low latency you'd want to build this kind of a construct on top of.
And that RF, so right, redundancy factor of 2.
2, yep.
Now, would you typically have you got to have at least a redundancy factor of 2 on the other side too, correct? And are we waiting on both those rights or just one of them?
both, but they occur, simultaneously.
Mhm.
Yeah, so that latency we're talking about, potentially that 4 milliseconds, only has to happen once, and then once it gets to the other side, it's writing that second write locally.
Yeah, because don't overthink it. Like, it's the cluster sending
Right.
data to the other cluster. The cluster won't acknowledge it until a write is compliant with the RF.
Right.
So you sort of are waiting on both, but you're really just waiting on the cluster to acknowledge it.
Okay, so it's the cluster, it's the brain of. Hey, quick question for you. It doesn't mention. I did a quick search. We have to have Prism Central to pull this off, or no?
We actually do, not really for this one, as Jerome's written up in his lab. But yeah, not fully required. Recommended. Adds a lot of value to every environment.
Yeah.
Right.
If you can see what I'm doing, I did a path ping out to yahoo.com, and I'm working my way down the chain until I start seeing more than 4 seconds a millisecond.
Well, so remember that often there's some black magic going on there, right? If you say, if I try to ping Google 8888, right, or 8.8.4.4, either one, that's a magical IP that like can have a responder closer to my house than, say, California, right? So there's some I don't know enough to know if that's like BGP funniness or.
I'm actually not trying. Yahoo in this case was 30 something milliseconds. I'm pinging things that I found via
In between.
along the way.
Yeah.
Through a path ping. Impressive, huh?
I don't even know what a path ping is. Interesting.
It's like a trace route.
Trace route hop.
Yeah, it's kind of like trace route, but it gives you, I don't know, a long time ago I learned it and thought it was the most amazing thing when I was using trace routes. And I started using path pings.
Interesting.
Now, you learned something.
Worth calling out, like almost every time that you entertain this kind of design with Nutanix Metro, this is going to be over your either private lines or a VPN tunnel or dark fiber. You wouldn't really do it over the real internet.
Yeah. Another good point. You don't want this to go outside your network and come back in.
Well, it could add dramatic unpredictability to latency.
Exactly. Yeah, exactly.
Well, and so the very first time I experienced this, I had a university. They had 2 data centers across the parking lot from each other, and they had super low latency, and they had redundant fiber that went out the back of the building, out the front of the building, under the parking lot, around the parking lot. And they actually didn't go with a metro cluster. They ended up going with just a cluster, and they put 2 nodes in one building and 2 nodes in the other. And the Nutanix guys were looking really not happy with that, but they did it, and it seems to have worked. Is that common, Jirah?
Not common, not recommended. Glad it's working out for them. But I would also postulate that that's probably untested failure, primarily because we never recommend, with any distributed system, right? You wouldn't want a quorum violating amount of nodes to be able to be partitioned, right, or split brained. So if you have 2 and 2 and then they can't communicate, neither one really understands which one is the quorum, and either of those failures constitute like an RF violating level of failures.
Yeah.
Right. If you've got 2 and 2 and one of those sites goes down and now you have 2 of 4, then you're not in a good position to recover from anything. I mean, I guess everything at that point will begin thrashing, trying to figure out where the other side is, because you need at least 3 for RF2.
Well, or you need at least 3, but also a 4-node cluster, you can only configure RF2, which is a lose one of anything type of scenario, and instantly we've lost 2. So we're kind of already in a bad way.
Yes.
Well, and I guess the thing that made it slightly okay was the fact they had lots of redundancy, which physically that might have been okay, but still could have been a human error that could have wiped out that redundancy. And next thing you know, everything's going crazy, thinking it's the only thing left on the planet.
Absolutely. Yeah.
I mean, it wouldn't really go crazy, but I'd have no expectation that whichever one you call the surviving side here is like okay with it and just keeps on running as a pair of 2, right? We'll just stop all operations, wait until we can restore cluster health, and then resume forward in time. We're actually, Nutanix is a remarkably resilient platform in terms of like taking good care of customer data and accommodating the unexpected. But that accommodating can often be like, we'll just turtle up and safeguard your data until you heal the network. And now we get back up and running.
That sounds like my life at home. Something will happen. Everybody just stops. So wait for dad to get home. It's like,
oh, there you go. There you go.
Someday my kids or my wife is going to listen to this. Never mind. They're never going to
something
listen.
sort of literal split brain. Yeah.
Yeah, well, I was gonna say good for you that they turtle up and wait for you to get home. I'm sure that's annoying, but not as annoying as they continue to just go further and further down that rabbit hole. So that then by the time I get to it, it's 10 times worse than it was when it started.
Well, honestly, my boys will definitely do that. Like they'll just keep wrapping the string around the lawnmower blade until it just is unfixable.
Yep, that's what I expect.
Okay,
so we've got our two Nutanix clusters, one cluster per site. Each of them has those data stores, those containers that are from me to you and from you to me replication created on both sides. Then we want to add all nodes to a VMware cluster in vCenter. One cluster, right? So this is a key point. We're going to use two Nutanix clusters, add them both to one single vCenter cluster. Reason for that being is because when we're using ESXi as our hypervisor, the management and control plane dictates that the HA boundary is at the cluster level. So you can't have vSphere HA from one cluster to another. So that's why we want all nodes to be in one single vSphere cluster.
Mm-hmm.
Okay.
So it's intuitive once you think about it, but some people might on their own think they want two clusters, which would be an accurate geographical representation, but we actually want the opposite. We want one logical cluster with two participating Nutanix clusters within it. Once they're in there, there's some accommodation here given for like how VCLS gets placed, right? The way that vSphere does modern HA. That, of course, is fine. Doesn't need any real tinkering. You just create a VCLS data store for each site because those VMs won't migrate, won't move. Within that, then there's some recommendations here around DRS, right? Basically, leave DRS fully automated, threshold 3. Of course, no power management, no advanced options. That's all pretty straightforward. Some flags here around the APD handling for each host for how do we want to handle APD events. HA handling, of course, monitor VMs for availability, on host failure, restart VMs, emission control failures, right? For most RF2 clusters, tolerate one failure. For data store heartbeat, right? So like the two Metro data stores, and then advanced options can also stay empty there as well. So now at this point, we've got our containers created, our Nutanix clusters created, our single vCenter cluster created, and we've got our DRS and HA options set on both of those two clusters.
Hey, Jirah, where's vCenter living in this world? Does it matter?
So ideally, the book says the most right answer is it lives somewhere else, right? We don't want it to necessarily be on one of these clusters that it is protecting. For Jeroen's lab environment, he actually calls out that he even does that. But there's considerations for like an actual production environment where if you're going to go do this for real for your day job, vCenter should go elsewhere, right?
Yeah.
And there's actually a reason. We'll get back to this. So we'll also be creating later on a witness VM. Witness VM absolutely has to be outside the cluster that it's protecting, right? So it's going to be witnessing which of my two surviving clusters is already alive, which one's my survivor, which one's offline. So we already have a third availability zone, right? For the witness, vCenter should go there as well, probably.
And Jirah, maybe we're going to get into a section down below here where it talks more about the witness. Is it a witness? It's a witness looking at both clusters. Is that how it works?
Correct. Yep. A witness, both clusters, both can see it, both get registered to it. Yep.
Is that, does anybody at Nutanix offer that piece as a service, like external? Or maybe I just came up with a business model, but does Nutanix offer that as a service, or is it a VM that lives on the network somewhere?
It is a VM that does live somewhere on your network. In terms of as a service, I mean, I sell Nutanix clusters as a service that can run witness VMs, but also in a less jokey way, you can even run that anywhere you want it to, right? You can run it on non-Nutanix, right? On anything you wanted to. You could run it on a Nutanix cluster in public cloud, anywhere you needed to. You wanted to treat like a third availability zone.
Yeah. Okay. There's not a lot to those things. It sounds scary, and then you do it one time, like, oh, well, that's all I do.
No, it's very lightweight. All it is basically just, I'm sure it does more than this, but basically it's just there to register heartbeats and then let someone know that it's the survivor. And if they can't see each other.
It's some kind of virtual appliance, right? It's not a Windows box, is it?
Correct. It's a virtual appliance.
Not a container at this point, but a virtual appliance.
Correct. Also not a container. It's a virtual appliance.
Okay.
So then one additional bit of construct here, right, is going to be creating host groups and affinity rules within vCenter. So what that means is that we want to teach vCenter, right? I've got host group 1, host group 2, and then we'll also then create some should rules within vCenter to say these VMs should run on cluster 1, these VMs should run on cluster 2. Because obviously, A, we want data locality, B, we don't want all the writes getting dragged across to the wrong cluster, because each storage container, right, each data store is owned by one cluster or the other. So we want to make sure that those VMs get preferential access to where their data actually lives and is readable.
And what do you see mostly in the field? Is it pretty much one cluster is loaded up and the next other one's twiddling its thumbs waiting, or do people kind of divide out the workloads?
You could do either one. There is probably no real need to go for full and empty, because statistically, I would hope that as you're planning this as a company, your data centers have hopefully equal risk, right? There's not one that's like more likely to go offline than the other. If that is the case, if one, goes down every third Tuesday for inexplicable reasons, then sure, treat that as the empty one, right? And plan to run no workloads there. Yeah. But for the most part, most companies would prefer to run with like balanced workloads, right? And most application servers would run that way too, right? Run half my domain controllers at one site, half at the other, half of my web servers at one and the other, deploy AAG databases with a leg on each side, right? So it's better in most ways to split my workloads across those. But you could do either one.
Yeah. I think the reality, at least it has been up until recently, is you had the old building that was the data center. You built a new data center. Now the old building became the backup, and it never should have been the data center to begin with. But all we can afford is one. But now with the world of colos and cloud, that has gotten better.
Yeah, it'd be my hope, but it is just that a hope that with high quality modern colos, that having two data centers, neither of which is inherently more risky than the other, can be an easy reality. So we've got our rules in place that certain VMs should run on one site, certain VMs should run at the other site, and then we get here to deploying the witness. So we deploy that as a virtual appliance, give it an IP address, and then we within each Nutanix cluster register those clusters with the witness VM. So they both check in, they're heart beating to make sure that they are online. So then,
how often are they touching it?
I don't know. Very often?
Yeah, it must be like almost nonstop, right?
that's a technical answer. I would assume, that's got to be very, very frequent.
Yeah. Okay.
Mailed a postcard once a week. That should be fine, right?
Yeah.
So we can deploy it in your lab if you want to, Andy, and then we can packet sniff and watch how often those things call each other.
Yeah, well, you and Harvey can do that. Let me know.
So you're not that curious. Okay, interesting.
I just have other things. Of course, Harvey does. We all do at this point. But maybe, what was the guy's name? He had a really cool name. Guy who wrote the blog. Jerome. Let's just ask Jerome. I'm sure he knows.
There you go. So the last thing to do then is turn on replication, right? So we're going to replicate, and we named our containers very meaningfully, right? From 1 to 2 and from 2 to 1. So we go in and enable replication in that direction, named in the container. And that's it. That is the end of the setup process. We've talked you through it in the span of a single podcast episode. So then what does this let you do? For one, right, of course, you can now live migrate across clusters, right? Because vMotion within a data store, vMotion within a cluster is super easy to do at the vCenter level. So that lets you get your live migration. And this is where we opened with scenarios where you can do planned workload migration to avoid, say, planned data center maintenance. So that would be easy, right? And now we're back to rerouting around traffic on the way to school. So with that, I can, turn off, either update my DRS rules or turn off DRS. Probably updating the rule is better. Update my rule to say these VMs should run at the other site. They'll migrate over, and then I can activate their container, right? So I can take the data store named 1 to 2 and activate it at site 2 to make it writable there. So then I've moved all my workloads into one basket, and now I can do maintenance back at data center 1.
Yeah.
And then I can move them back over. So I've got my live migration across data centers there. Pretty easy. And all I'm really doing is touching my DRS rules there for where that should rule will place my VMs. But then the other real outcome that most customers want to look at this for is that, the smoking hole data center goes dark at 3 a.m. kind of scenario. And my VMs are an HA event away from recovering at the alternate data center. So
Yes.
that sort of no human touches a button, but all the workloads come back up. Is usually that's really the planned, data center migration maintenance is a nice to have, but really the must have is the no data loss, all data written across to another data center before it ever gets acknowledged, and then auto workload resuming across the wire there at the other data center are the real huge deliverables.
So Harvey's probably had more interaction with this than I have. Most of my world has been around VDI and building, non-persistent on one side, non-persistent on the other, put a controller over here, controller over there. And if one went down, all the other stuff just kept going. And I ran at half my load, but I still had something available. Now, where it really becomes interesting on the VDI world is all those persistent desktops that, they can't live in both places at the same time. This all of a sudden solves that challenge. And there are lots of rollouts where they have hundreds, if not thousands, of persistent VDI workloads that need to be available if one data center was gone, one side of the cluster was gone, metro cluster. Harvey, this one's always been fascinating to me, so I've kind of dominated. Any specific comments or questions or thoughts on metro clusters and what you've seen?
I mean, for me, it's what I would have expected. I mean, not a lot of, we shouldn't say not a lot. There are lots of customers who do get this kind of flexibility because they have those sites that are geographically available for this, something that's open enough or fast enough or low enough latency that they can pull this off. It doesn't happen for everybody, so it's not something that I'd say I run into very often, but it's definitely something that I've run into often enough that, it's good to know the ins and outs behind it and how you can set it up to test like Jerome did.
And some of the key, like, what does it not call out? Like, you don't need specific node types, not a ton of virtual appliances to deploy. It's the one witness, right? And beyond that, you're just using regular Nutanix clusters to do it.
So Jirah, that brings up a couple of things. Let me ask the one question just popped in my head. I guess you got to have at least the same amount of storage capacity on both sides. If you're going to be going from each direction towards each other, you got to have enough storage to cover that replication, right?
I don't know if it's a hard requirement, but boy, I would sure recommend it. Yeah. Otherwise life gets pretty interesting.
Yeah. And then we talked all through this article, this blog about doing it with VMware. It probably just gets us even slightly easier, if not a lot easier on AHV or no?
Correct. Yeah. Because in this one, right, we're sort of using the construct in vCenter of HA is a cluster property. Nutanix already knows when it's managing an AHV environment that each cluster, has its own HA control plane. So the steps look a little bit different to set it up, but yeah, the VM recovery automatically across sync-up on AHV is also possible.
Yeah, cool. Well, guys, I think that wraps it up. This is very interesting. This to me is a little more interesting than Red Hat OpenShift, I have to admit.
Sorry, Red Hat.
Well, it's good stuff. It's just not how where my passion's been. There was a brief 3 months there where I tried to become a Linux server guy in the early 2000s, that and a Unix guy. And then I ended up not making it. I ended up back in the Windows and the VDI world because I thought it was more fun. But I get it. I love getting down deep into kernel and commanding myself away.
And both are important. You could use this to protect your Red Hat OpenShift environment for sure.
Sure. Well, guys, happy Monday, and thanks for joining. And this was fun, and we'll do it again in a week.
Happy Monday.
Absolutely.
See you guys.